I want to give you a little bit of context about what I'm talking about, so it'll kind of help you see some of the trade-offs and decisions that we made, because they might not be for you. So keep everything kind of with a grain of salt, understand that we're making decisions based upon some certain context, and I'm not kind of saying anything's better or worse than anything else. So the context is we're building a new native mobile app. This is horrendous. These are some of our early screens from our mock-ups. This is not what is live, but they kind of indicate what we're doing. So Redbubble's a marketplace. We essentially sell artwork on products. So we have about 17 million artworks on the site, and we have about 60 odd products. We released a new one today, so I think we've got 62 now. And that combination combined with colors means we've got a massive inventory of potential things we can sell. So we're what we call a long tail business, which basically means that the things that we sell, we only sell very few of them. So I think our highest selling thing sold about 20 times. So we're kind of for independent artists, and we kind of give you a unique t-shirts, unique mugs, whatever. So you can go and find the art that suits you and you can print it on things. So we're trying to give our customers that experience of finding the thing that's for them. So we had to build this new app. We've got an existing Rails monolith. So I don't know about Sydney and I don't know about other areas, but everybody in Melbourne has a monolith and it's written in Rails. And everybody's trying to break up their monolith and split it into microservices or whatever you want to call them this week. So we're building a new service outside of our monolith. So the constraints that constrained us in the monolith no longer hold. If you're as old as I am, you would have heard this thing called probably a proxy API, or even a backend for a front end, or a BFF, if any of those words mean anything to you. So we're building like a facade across the top of a bunch of underlying backend services, and we're also building out that backend service at the same time. The developers on our team are mainly Swift developers, so they're used to kind of a type-safe language. There's no Ruby experience, even though organizationally we have a lot of Ruby devs. They didn't have any Ruby experience. And we've done a lot of modeling around our potential load on the system with the number of users and stuff, you know, as compared to the website. And we would have had to have run in the vicinity of 50 to 70, I think, from memory app servers to maintain the load that we wanted to if we had have built this thing in Rails, which was what our monolith is built on. That's actually how many app servers we have for our website. We were doing a bunch of stuff with React Native. So I don't know if any of you guys have seen React Native. We do a lot of prototyping and rapid iteration. We do lots of user testing. So we were going and talking to users probably twice a week, like actually getting them into the office and running them through prototypes. We're also doing online testing. So there's a service, usertesting.com, and there's a whole bunch of them that you can run online user testing through, and you can submit a binary and they go and download it and they test it, and you get to basically voyeuristically watch what they're doing. And so we're doing a bunch of that, and React Native is really great for kind of knocking those things up really quickly. And React Native has really good support for GraphQL. So we kind of came to GraphQL kind of the side way, I suppose, in that we had React Native, we were prototyping things in Framer.js and then React Native and also Quartz Composer, and we kind of just fell into GraphQL because it was really easy to spin up a GraphQL endpoint on top of our existing monolith, and we were able to prototype those things out really quickly. We had some other issues too. We had, I think, two or three client-side devs working on our kind of prototype ideas for our app and testing them, and we weren't able to evolve the backend fast enough. So we weren't able to produce the endpoints, like literally write the controllers in our monolith to be able to feed their needs quick enough. And GraphQL let us kind of get over that because they can just do whatever the hell they want then if we provide the data model. And you'll see what that means in a minute. Okay, so that's the big boring context as to how we got here. So assume we have this list of products. So we do have a list of products, and we want to produce a HTTP API to go and fetch some details about that products. So we make this curl request, and what do we get back? So it's not obvious, right, what we should get back, and depending on who you are and what you want, it's not obvious what data you want back either. So should we return, say, the IDs of those products so that we can make a subsequent call? Remember, we're building a mobile app, so making lots of calls is chatty, and it's probably not something we want to do. And because we're building a mobile app, we probably don't want to produce a whole lot of data. But what happens if we're building like a list screen that has not much stuff, and then we've got some detail screen that has lots of things? So we've now got several use cases for the same API. So we have to make some decisions around the kind of data that we want back, and what do we want back when, and what do we want back where. So let's take a concrete example. This is an actual product from one of our product APIs. I've cut out a whole bunch of stuff because it's a lot bigger. So there's lots of stuff here, right? That's one product. And like I said, we have, for every single work, we have up to sort of 60 odd products that work's able to be printed on. So you could ask, for example, for the products that are available for a work, and you'll get 60 of them back. That's a lot of data. What if you just want the titles? What if you just want some details about the artists? So you might want to know the name of the artist that produced that artwork. We have another API that, given an identifier for an artist, which is their username, we can go and fetch their details, like where they're from and what their profile is, what social networks they're on, things like that. So all this is redundant in this API because we can go and fetch that. But again, we've got the same problem. We might be able to get a username back, which is the identifier for an artist, and then go and make a subsequent call. But do we want to make, if we get 25 results here, 25 calls from the mobile app to a back-end service? So that's really wasteful, and extra data is really wasteful as well. We can go through the same argument with ourselves around pricing. When we first launched our app, we only launched in Australia, so we didn't need multi-currency. We launched in the US today, actually, so we do now need multi-currency, but thank you. Please go and download our app and send feedback. We launched in New Zealand too last week, and we had 4 users, which was awesome. One of them was one of our developers who's from New Zealand and went home for a holiday and convinced 3 of her friends. I'm not joking. No, I don't know how many users we ended up with in New Zealand, but we had 4 purchases in the first 2 days. But we did launch in the US today. So we can go through the same kind of argument around currency and talking about the things that we do and we don't need. We can talk about the same thing if we're rendering this thing in a list. What sort of data do we want to return? The underlying problem with all this is that our API is fixed, right? The people building the API are defining what we want to return, not the people consuming it. So I don't know how many of you work in big companies, but in some big companies, thankfully I don't, there are like an API team that defines what the API looks like, and then there's multiple consumers. We don't work like that because we don't think it's very efficient. But even still, it can be hard to iterate as fast as you need to, even if you've got literally the person pairing with the person consuming the data. So let me give you a concrete example of what that might look like. This is taken from Spotify, I believe. The example on the left is a REST call. So here we're looking for details about an album, and then based on that, we're going and searching for the comments for each of those albums. So again, we've got this n+1 problem, and we've also got this kind of problem of independence between the 2 things that we're making. So if the second one is independent from the first, then we can go and execute them in parallel. But we have no way of knowing that, for example, kind of automatically. And if they're not, then we've got to wait for one to finish before we make the second one. If we look at the example on the right, that's the GraphQL example. We're making both queries in the same kind of call from the client. So there's only one request being made to the server to get that data. Obviously, these are contrived examples, so take them with a grain of salt. So some of the problems that you'll hear with building these kind of RESTful HTTP APIs are kind of listed here. We've got over and under fetching, so getting too much data than what you need or not getting enough, and then having no control over that. Multiple calls to get the same data. So for example, if we get back 60 products and then having to go and look up the artist for each one of those, then we're making 61 calls. You've got weak typing within that. I don't know how many of you have consumed JSON APIs, but knowing if something's a string or an integer, and is it going to always be a string or an integer, or is it going to be a float? I don't know. Who knows? It's JSON. Do you have things like, how do you encode null values for fields that don't have anything? Do you return null or do you drop the field? Like, there's no kind of good things around that for how you should do that. And it's very kind of API by API based. So we built a lot of back-end APIs into our monolith to power this. And even within the same team building the APIs in the same code base, they made different decisions because there's just no standardization around stuff. Like, how do you do pagination? How do you handle errors? How do you deal with HTTP status codes? There's no good consensus around this stuff in general. Documentation's quite bad. You've got to go to third parties like Apiary or tools like Swagger to go and get any API documentation. And probably the biggest thing that'll affect you a lot is the API is fixed. You have no control over that, as I've talked about. Now there are solutions. There are solutions in things like SQL for pagination. There are solutions in RESTful APIs. These are two examples from Google and Facebook. The top one's Facebook, where you're actually drilling into those things returned. But you know, the Google one's different. So there's not even a consistent standard for, do you encode that stuff in the query string? How do you represent it? What does it look like? I worked with a guy a few years ago that used to use bit masks for encoding this data. So there's different ways that you can do that stuff, and there's no real consistent standard. So now that we've talked about all the issues, GraphQL is going to come in and save us. So GraphQL, a friend of mine came up with this idea. Chris, who you might have seen talk from REA, he kind of said that GraphQL inverses this relationship between the client and the server. So rather than the server defining what you want and just giving every client what you need, what GraphQL does is it inverts that. So the client gets to request what it needs at the particular time. And it might change over time, and it might change depending on which screen you're viewing and which area of the app you're in. So it inverses the kind of power relationship between the client and the server. So this leads to some interesting solutions for a lot of those problems we talked about. Not everything, but a lot of them. So let's talk about what GraphQL is. I'm going to give a really high superficial view of GraphQL, by the way. So if you are coming here in 25 minutes going to be a GraphQL expert, you're probably going to walk away not being a GraphQL expert. But I'll try and identify some of the pitfalls that you'll go through when you're learning this stuff. GraphQL was developed by Facebook. It's been used internally for a long time. It was open sourced in 2015. It has support for a bunch of programming languages. There's both an open specification, which is that URL, as well as a reference implementation built in Node.js. And then there's a bunch of other things that are kind of added on the side that can be really confusing, like Relay and Redux and all these other things like that, React even. So I'll try and help you navigate through which things mean what. There's some kind of design themes that GraphQL is built on top of that might be quite familiar to us as functional programmers. So it has this notion of hierarchical fields. So what that means is, take the Facebook example, I'm a person, I have friends, those friends have friends, those friends have names, those friends of friends have names. So this kind of notion of hierarchy, GraphQL is built on that. This inversing of the relationship, they call it product-centric. So what they mean is the product, so the end client is the thing requesting the data that gets served to it, rather than the other way around. And because of that, you have these client-specified queries. So you give, it's like SQL, you give it a query and it gives you back some data. GraphQL is an application layer protocol. It doesn't care about transport, which might freak a few of you out, but we can talk about that in a minute. It's strongly typed in that it has the notion of types. It's a very simple type system, but you can't violate the types. You'll get errors in the type system. It's backwards compatible. The little hat there is basically saying it has a story around backwards compatibility. If you read the documentation and the hype, it'll say you don't have to worry about backwards compatibility. That's crap. You do. It has some support for things like deprecation that lets you not do stupid things, but you still have to say you're serializing as JSON. You still have to know what that means and how to do things like never remove fields that old clients might use, as a simple example. So you've still got to know about backwards compatibility. It doesn't solve all the problems forever. And it's introspective. So it allows you to basically ask a server or a schema, like, tell me your schema, tell me what your data structure is and how I can interrogate it. And you can get that dynamically by just like pointing a tool at a thing and getting some data back, which is itself in GraphQL. So what is GraphQL? If you're doing any reading about GraphQL, you'll find lots of things. It'll be very confusing. You'll be very confused between what is supported in the reference implementation, what is GraphQL itself, what is the application server, what is the transport, what protocols are you using, what encoding and serialization are you doing. But it's really just three things. So a really simple type system. So it's integers, strings, booleans, and some other nice things like whether fields can be nulled or not, as well as a schema. And that schema is basically you using the type system to represent your domain. So you can say, let's take Facebook's example. I'm a person is an object, so it's a key value pair structure, and it has a name, and that name is a string, and everybody has to have a name. So it's not optional, it's required. So that's the schema. And then based on the schema, you have a query language. And the query language is just a form of the schema that lets you query the data that you want to get back. That probably sounds really weird, but it'll be really obvious in a second what it is. So we talked about what it is. It's 3 things. This is what it isn't. So again, you'll get really confused if you read blog posts or anything because Facebook released the Node.js version. There's lots of stuff about Node and there's lots of stuff about JavaScript. And it's really confusing to know what is and isn't in GraphQL. And you'll see talks on GraphQL and they'll say, hey, there's this new feature when it's actually in the server, not in the spec. And if you're on a different platform, then that can be really hard to kind of disambiguate what it is. So it isn't a runtime to execute the query. So given a query, GraphQL doesn't tell you how to go and actually execute that. There are systems that do that, like Sangria is the one that we use in Scala. It's not an encoding mechanism, so it doesn't care about JSON versus XML versus some sort of binary protocol. It doesn't care. There's no transport involved. So there's no HTTP versus something else. There's no client-side bindings. Those things exist, but they're not GraphQL. So there's some nice ones for Swift, for example, that you can point to a schema, it'll generate you a bunch of code to interact with that server. It's not a server. So you don't get a server out of the box, and it doesn't tie you to a graph database, even though it's called GraphQL. So if you're coming looking for a graph database query language, that's not what GraphQL is, which is kind of ironic, but that's what it's called. And it's also not the tools that ship with a lot of the GraphQL implementations. So you're going to see GraphQL later on, and GraphQL looks awesome, and to me, in my head, that's what GraphQL is, but that's not what it actually is. It's just those 3 things we talked about before. So when I say it's not these things, I mean you're going to have to find these things somewhere else. You're going to have to go looking for a toolkit that gives you these things. And all of them do, but that's not what the syntax and the language is, so just be careful of that. So we've used it for probably, I don't know, 9 months-ish now. And I'll give you my view of what the killer features are of GraphQL. I know I haven't talked about and shown you GraphQL yet, so you'll hear me stop talking in a minute. The biggest thing I think is that GraphQL represents the domain. So we're able to say things like, this is the Redbubble domain model. Like this is the relationship between works and artists and products or shipping dates and things like that. And you're able to see that relationship and you're able to traverse that relationship interactively in a tool. That's really awesome. And we're able to aggregate across those multiple disparate back-end systems and kind of join them together. If, for example, I don't know, purchase information's in one and address information's in another and delivery information's in another, we can join those things together and represent them as a single entity in the GraphQL layer. It has a type system, which is awesome if you're used to integrating with RESTful APIs that don't have a type system. It's got this introspection and documentation facilities that make building queries trivial. They're really easy. And this last one is something that I didn't think was a thing, but if you've ever built any sort of RESTful APIs, you'll have to make a bunch of decisions and you just don't have to make those with GraphQL because they're kind of made for you. So I'll give you an example. If you're building Rails, for example, and I know you're not, but we do a lot of Rails, you have to build a controller and you have to build actions and you have to build routing and you have to figure out, are you going to do REST? Are you going to really do REST? Are you going to build things with plurals or singular names? How am I going to route things to those things? How am I going to pull the data out? All that's just taken care of. You can really quickly add new stuff if you want to iterate fast on the data that you return to your clients. Okay. So I'm going to give a demo. So I'm just going to kill my server. That's our live metrics, by the way. So the US is asleep, so I think there's not many requests going on. Okay, I'm just starting the server. If you don't believe me, I'll show you the log. There's our server. I'm going to go and I'm going to run a query. Hey, all right. So people at the back, tell me when you can read that. It's all right? All right, I don't want to make it too big because then GraphQL doesn't like big fonts. Oh, there's monitors up the back. It's like we're organized. So this is GraphQL. When I said this is what I think of GraphQL, this is what I think of GraphQL is. It's this interactive query builder that lets you build up interactively queries. So this is not GraphQL, but it ships. You can go and get it. It's from Facebook. You can integrate it into your server, or you can get a standalone tool. There's a Mac app that lets you like put a URL into a server and you can poke it at that and it works. So this is a GraphQL query. So this is one of our queries, and I'll just talk through this really quickly and then we can build it up from scratch. So it's hierarchical. You can see things are nested. Those things are named. I don't know if you can see the little squiggly line under featured feeds. I'm just going to hover over that. Oh, look at that. So this is GraphQL's backwards compatibility story. It lets you define things as being deprecated. So we brought in a new type of feed, so we deprecated all our old feeds, basically. You can still query for those, and we still have to support them because we have like thousands of apps in the wild that are making those requests, but we can no longer allow new clients to make those requests if we want to. So let's go and build this up step by step. Let me find my little thing that's going to let me. Okay, so what I'm going to do is I'm going to go to our website. So this is our website, and I'm going to find a product. So I don't know why, but I really like pineapple products at the moment. And this is a zombie pineapple. So awesome. If you love zombie pineapples, you can get it on a coffee cup or a wall hanging or whatever you want. So what I'm going to do is I'm going to go and pull that work ID, which is in the URL here. And keep your eye on this t-shirt. I'm going to go back here, and I'm going to put it there. Now, since we launched in the US today, I'm going to get our prices back in US dollars. Okay, so I've just executed that query, and yeah, it worked. All right. So I've got internet and that worked. So what I've basically said is give me all of the available products. So this is a query. Give me the available products for a particular work. So as I said, we've got 17 million artworks, and we've got 60 products, and I'm saying, and an artist gets to define which products those things go onto. So an artist can say, yeah, I love t-shirts, but I hate coffee cups, so I'm only going to allow it on apparel. And that's up to the artist to define what they want. Or they might say, I'm a photographer and I only want it on wall hangings because all that other stuff's crap and I don't like that. So we're getting back the available products, and we've asked for the things of them. So we're making a query, we've put some parameters in, and then we've asked for some particular value back. So this is the type name of a product. So this is like the type of a product, it's its name, it's its human readable name. So women's relaxed fit t-shirt is the first one. And you can see we've got a lot of them. Notice how the structure of the query matches the structure of the output. So this says available products, and this says available products. This is going to return us an array, and so here's our array. Type name is called type name. So we can do things here if we want to. We can rename that to name, or we can call this, peas if we want to. Whoops. So we can start to play around with that. And this is all built into GraphQL. This is nothing special. We can change the names of those things if we want to. And the structure of the input matches the structure of the output. We can interactively find out more about these things. So we can ask, for example, for its price. And price has an amount. So we can ask for its amount. Let's just emit that amount and see what happens. So you can see I get a little red squiggly here, which is basically saying this query's bad, you can't run that query. But then if I do actually run it, because it's just a string, right? Like there's nothing going to magically prevent us from sending that to a server. We get back some sort of message, and it's reasonable because it's got this little thing here that tells us where the error was. And there's some interesting things about that response. So we're always going to get back, and GraphQL guarantees this, either a data element or an errors element, or both. That might sound confusing, but I'll tell you what that means in a sec. And if we get an error, it's always going to be errors, and there's always going to be an array, and it's always going to have a message. So that's like guaranteed. So there's some level of standardization around this stuff. So let's put the amount in and run that again. There's a whole bunch of caching in here, which is why it's coming back quickly. So a women's relaxed fit tee is $28 US. Great. What else can we find? Maybe let's find an image and a URL. So if I take this URL, I should be able to get hey, I've got a women's relaxed fit tee with that particular artwork on it. So you can start to build these things up interactively, which is really great if you've got kind of a decoupled client versus server development, and you just want to let your people experiment with the APIs that you're building for them. Works really great. We have a lot of designers that do prototyping around this stuff, so it works really good for them for doing that kind of stuff. Where they haven't really figured out what it is they're trying to build, they're just kind of experimenting. We call that discovery. That's a special kind of phase that we work through. So it's really handy for that kind of thing, and that's where the whole kind of domain model makes sense. One thing that's really interesting with GraphQL is there's no kind of ability for you to select or kind of give information that says, for example, you can't say, find me all the available products, but find me only those with women's in the title. You can't do those sorts of queries with GraphQL. It's a very basic query language that basically lets you select which things you do or you don't get back. So you can't, for example, say, tell me how many results I've got. That's not a thing. You have to build the support for that.
So you do have a query on available products that does have query.
Yes. So that's the way you have to do it, Jed. You have to pass parameters or arguments to, those things are called fields, and they're just like effectively a function name, and you're passing arguments to your function. And you can pass an argument, but you can't then do aggregate functions on those things. Like you can't go, given that thing back, give me all the things where that thing's greater than 5. You can't do that. You could build that in. You could say, you know, greater than :5, but you'd have to build support for that. It's not a function of the query language. So it's not like a true query language, I suppose, if you're used to using SQL or something like that. But it's like a query language for non-RESTful APIs, if that makes sense. And the last thing I want to show you on this, just let me get my cursor back, is the introspection query. So this is an introspection query, and I'll run that and just show you that you can get details back. So all the introspection queries start with __, and this is saying, give me back the type information for this particular thing. So you could think of that as a class called product category, and it's an object, which means it's like nested key value pairs or an associative array if you come from JavaScript, and it's got a name and it's got a description. And the same thing, it's just a query, so we can ask for stuff about it. So we can say, what are its fields? What are their names? Okay, so product categories have names and products. So a product category might be men's apparel, say, or homewares. And it has a name and it has a set of products that come with it, and you can interactively build that up. And what you end up being able to do is to be able to generate documentation. So this is all built from the schema. We've done nothing here, we've just defined the schema, which is what you have to do to be able to query it, and then you can pull data back. So this is our query API, this is our read-only view of the data, there's also like a write-only view, and these are all the things that we can do with our API. So we can pull back details of works, we can find works related to other works based upon a bunch of parameters, available products, which is what we just saw, details of artists, and other things that scroll off because GraphQL doesn't like zooming. So just through the introspection, you can get all of that data back from a server. So you're able to build these rich tools and also, you know, client-side generators for bindings.
Yeah. In this example, how do you store your data in the server?
Great question. We don't. That's going to sound weird. We built a proxy API, like an API that aggregates other services. Let me count how many services we've got. Hang on, I've got the code here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, oh, it's stopped. 19. We aggregate 19 back-end services. So there's 19 APIs that are built into various systems, and we aggregate them. So for example, if we ask for available products, what we'll do is we'll ask an API for the available products, and then we might look up subsequent APIs. So we're effectively making downstream networking like HTTP calls against those other services and then aggregating that data. And then we've got a caching, we've actually got 2 caching layers that store that data. So it's a completely stateless system. There's some state in that we have a cache, and there's a little bit of state in that there's like some configuration in the code. So some of our categories are hard-coded because our app behaves slightly differently to our website. And we've got a team fixing that, but they haven't finished yet, so we haven't used that stuff yet. So there's a little bit of state in the code, but mainly it's purely stateless. So that's another big thing with GraphQL, is that it doesn't require any particular data structure. So it might look like we've got a database under that. We don't. We've got a collection of whatever I said, 17 back-end services that are all powering that different bits of that thing. And when we're building a feed, for example, so I'll run you through the feed. So we have a feed that is, I'm going to say it's personalized, but it's like a hacky version of personalization. So when the app starts, we'll say, hey, what are you interested in? And you might say, I love cats and unicorns. And we'll go, great. So we go and hit a service to produce your feed, and we say, hey, he likes cats and unicorns. Give me some products for cats and unicorns. Sorry, give me some works. So it's basically a search against our search infrastructure. Gives us back some works that match cats and unicorns. We then go, okay, great, we've got some works. Now go and figure out what products those things are available for. So we go and make more calls to say, okay, work ID 3 and work ID 6 and work ID 10 is available on these products, and we get back those things. We might make subsequent calls as well to find, like, I don't know, when those things might ship. Like towards the end of the year, if you're buying a coffee cup, that might come from Germany. And if you're buying a t-shirt, that might come from Brisbane. And so you're going to get the coffee cup before you get the t-shirt. Sorry, you get the other way around. You're going to get the t-shirt before the coffee cup. So we'll give you that information. And we might do that synchronously in that request on the back end. And we're aggregating that data and we're wrapping it up. And we're doing multiple things. We use a library called Fetch to do that, which, if you like buzzwords, it's a free monad library. Go and look it up. There's other ones in Scala. There's Clump, which is by SoundCloud, and there's one by Twitter called Stitch. It's like Haskell if you've used the Haskell version. It lets us cache those things, and it intelligently, so if you make a request for something like something with an ID of 1, and then subsequently in the call chain you make another request for the same thing with an ID 1, it'll go, oh, you've already got that, and it'll give it to you. Or if you make subsequent requests, like say you get the works and then you get products, and it's already got those details, it can deduplicate those, it can batch things, and it does that automatically for you. There's no work on your behalf to do that. So there's a bunch of stuff behind this. There's no database. Well, there's a database in those back-end services, but there's no database in our app. I'm probably running out of time, Jude, am I? Brian might say otherwise. So I can either go back and I can talk about GraphQL, or I can answer a bunch of questions and I can show you some code or whatever.
Can you talk about how you might wire it up to something like a fetch system?
Yeah.
That sort of relational, like,
Yep. So I'm gonna switch to
yeah. Fortunately, you had a window available.
here's one I prepared earlier. Well, when I gave this at the Scala Melbourne group, I spent like 15 minutes talking about that stuff, and then I got like an hour and a half of questions. So I just basically showed code. So I figured that might be the case.
Also, are there any Haskell backends?
I don't know, actually.
Somebody's starting to work on it. Somebody's made the parser. I don't know the server yet. Tom,
Yeah.
are you planning to talk about the event side of things at all?
The event side of things. What does that mean?
You can do updates through GraphQL.
You can do update through subscriptions. Yes,
Yeah.
no, I wasn't planning on talking about that.
Okay.
No, and I actually don't know a lot about it, to be honest, Ben, because I haven't done anything with it. But there's this whole subscriptions, I don't know what it's called, package that kind of extends GraphQL that lets you do kind of server-side event-based things. So you can, I don't know, is it like WebSockets or something? Or over the top of WebSockets?
It's kind of like CQRS, like embodied into it.
Right.
So you've got your query side of things, and you've got events that can flow down. That's how Relay does its stuff, because you've got your events flowing back into the Redux thing, and yeah.
All right. So to answer your question, hang on, there's a presentation mode in here. Where is that? Does anyone use IntelliJ?
Charles, you use IntelliJ?
Oh, it's really small still. That's pretty shit.
That's fine.
Okay, so when I said there's a schema in GraphQL, so this is using Sangria, so take this with a grain of salt. If you see examples of schemas online, they'll mostly be I don't even know what it's called. There's like it's basically quasi JavaScript. It looks a bit like JavaScript, but it's like, I don't know, the schema format. But this is the Scala version of that, and what I mean by that is it's the Sangria version of that. So you basically have this thing that represents your schema, and like a lot of things, it's just an object, and then you plug it into the thing that executes your schema. So there's like a thing that, given a schema and a query, which is essentially a string and some other bindings like variables and some other contextual information, it goes and munges them together and then goes and does the stuff. So the schema is effectively fields. So the fields have types. Those fields have subfields that themselves have types. And then the second thing is that there's a thing that knows how to go and resolve the values of the field, and that's called a resolver. So you can think of that like the function body. And for a lot of these things, it is the function body. So this is our API. It's a query API, and we just mix in a bunch of modules that give us all of the things. So this is really small. So this is the top level of how you get into it. So I will eventually get to your question. So you give it some descriptions and then you give it some things. So these are the fields. So we looked at the featured collections field. Oh no, we looked at available products. So where's available products? Here's the available products field. So I apologize at the back if you can't read that. I don't want to make it too big because it'll go off the screen. So available products has a name. So this is the thing that you put in the query. And then it's got a bunch of arguments. So these are like parameters to the function effectively. And then this field type is the thing that gets returned. So if you ask for available products, you're going to get a list of products. Yay. And no. It is a GraphQL structure that is backed by a case class. So normally there's a mapping between so there's like your internal data structure, whatever that looks like, and then there's some external mapping of that. And you can derive that stuff automatically. So there's like macros and all sorts of magic for being able to derive that automatically. But I like explicitness and I'm old, so I don't like all that magical stuff because that's what Rails does, right? And I've done lots of Rails and it's shit. So I would rather list them out explicitly rather than let some magic tell me what that looks like. So, yes, there's a case class called product, and let me open that and you're going to wince. And it has a work ID, and I expose it as work ID, but what happens if I want to change that? Or what happens if I want to add a second one and call it WID? I have no control if I use the macro. So yeah, you can get up and running really quickly, it demos really well, but if you're actually writing real code, it can be a real pain in the ass. So I've got available products, they return a list of products. It has some description, so you can see it's wrapped in a sum, so that means that it's optional. That gets exposed directly into the introspection query so that the documentation can be built on it. And then here's my resolver. So this is effectively just a function that takes a context, and the context is information about the query. I'm not going to talk about any more than that, except it's the context the query is executed in.
It's the Postgres query handle, so connection.
Could be, yep. In this case, it's things like you can pass a context a bunch of data and you can get access to it there. You can store stuff in the context within your query execution and then come back to it somewhere else. Like say you're asking for, I don't know, friends of friends, and you store something in the top level, and as you're executing friends of friends of friends of friends, you might want to get something out. Then you can store that stuff in the context and propagate those values. So it's kind of like a global variable available during query execution. It's not available across query execution, but it's available within query execution. That's a Sangria thing. I don't think that's a GraphQL thing.
Is that where one would put something like emissions?
You could put permissions in there, yep. Sangria's got a really good wiki that talks about common use cases for that. We don't do anything like that. So we have an API that uses HMAC on the front end, and then everything, once you're in, and that's it. We don't have any authorization. So I haven't had to deal with that, so I don't have a good answer for you. And it's just a function, right? It's just resolve, takes an argument and returns something. And it's going to return one of these because that's what it says. And it'll give you an error if it doesn't. And it'll give you an error at compile time, which is awesome. The level in Sangria is actually pretty damn good at giving you error messages. It's very rare you'll do something that it won't catch at compile time. There are some things that can't catch at compile time, like if you passed in an empty list there, for example, and you made it compile there are some things that you could potentially do. Well, actually, if I did that, probably, that will... Anyway, you can generate an example like that that will compile, but when you run it, it runs some subsequent checks and it won't boot up your server if that's the case. Well, it'll ask for something. I can, what does it want to do? It wants an output type. No, I can't type none there. There's a way to make it fail in a manner. I've done it a couple of times that the compiler won't catch it. It's very few and far between. So to answer your question, basically all you're doing here is taking stuff from the network, say you're unmarshalling it, you're pulling it into like the GraphQL structure, so Sangria is doing some stuff for you, or your server layer. So we're using Finch, which is a HTTP server built on Finagle, and it does that unmarshalling of the JSON payload for us, and it turns it into some data. And then kind of from here on, it's whatever the hell you want to do. So if you're talking to a database, you do it there. So all Sangria is really giving you is a thin layer that says, hey, I know how to execute arbitrary queries and turn it into things that I can go and do stuff with and reassemble that data and return it and do things like selection and projection, things like that. It doesn't have any care whether you use, in our case, that's actually going and making network requests. So if I drill through to here, here's our fetch. So this is basically our details of what a fetch is going to do, and then we run it in a future. And if I drill into here, you'll see that I'm pulling the products for a work, and then I'm mapping over them and filtering which ones we actually support in our app versus not support. So I'm just going to drill down, more fetches. This is where the magic happens with batching and things like that. And at some point, we go through and we talk to a backend and we make a network call. Hey, there's a get. So we're making a get on our works API. So you'd basically rip all that stuff out and put in a database layer. So it has no opinions on what you do or what you use. It's only kind of for allowing you to build these APIs. And you normally package them up with a HTTP server, although Sangria doesn't do that out of the box. It's just a GraphQL library. Now at the back. I can repeat the question, Jed.
Just real quickly, this probably applies to GraphQL in general. How do you deal with, like, think of a pathological case, like I've got a user,
Yes.
I've got a post and a bunch of comments, and they have users which have comments or
Yep. Great question. Let me show you. You hard code a max query depth. So there's actually two answers to your question. So there's. Sorry.
cross-based things as opposed to just
Yes. Yes.
You almost exponentially going.
Correct. So Sangria, and this is Sangria, not GraphQL. Sangria builds in this notion of a cost, and you can basically assign costs to different aspects. So fields can have a cost, and it calculates the cost, and you can set a bounds on that cost. So you can do that. The latest version of the spec that came out, I think, 2 weeks ago, that I'm not sure if Sangria supports yet, lets you basically, I'm going to call them stored procedures just for ease of talking about them. It lets you create these stored procedures on your server. So they're basically queries that you reference, and you can pass variables to them. And then you can make, say, a GET request and say, hey, I want to execute that available products thing and with product ID number 1, and it goes and does it. And there's a couple of benefits to that. One is GraphQL usually are posts, which means they're not great for caching and proxies and things like that. So it avoids that by doing gets. Yeah, you screw your nose up, but that's kind of okay. I'm willing to deal with that for the other benefits. It's all a trade-off, right? I've lost my train of thought now. Hi.
Ripping it out of the client to have store like
Oh, gets, yeah. Anyway, lots of people were doing this in an ad hoc basis. So Facebook had been doing this for years. So if you use the Facebook app on your mobile, it's basically got a bunch of references to queries that exist on the server. And all it's doing is doing a get against those queries. It's not actually sending the payload, because there's quite a lot in those payloads, right? They could be huge. So it's just referencing the query by name, and it's making a GET request with that name in the query string. So it's really small, and then it's getting the data back that it needs. So that's another way that you can lock down what you're able to query. I've never built a public API with GraphQL. So GitHub have a public API. BuildKite, if you use BuildKite, they have a public API as well with GraphQL. Well, when I say public, I mean you've got to provide a token, but it's for the general public. Ours is an internal API for a single client. So the security and the concerns around that are different for us. So yes, there are tools, but I don't have a good answer for you as to how effective they are or not effective. Yeah, hang on, we've got one at the back.
Is there any capability built into query planning across some queries?
Query what?
So, say if you need a common user that
Yes.
passes up across different subqueries, is there any way to optimize across that?
Yes. So Sangria supports a thing called, I've got to get the name right, deferred fetches, which basically let you do that. And we don't use that in Sangria. It's really simple to use, but we wanted a general case thing, so we use fetch to do that. So fetch is a library that lets us do that. And you saw some of the fetch code before. Let me drill back up. So for example, this says, this is the fetch that defines the products that are available for a work. So the parameters are work ID and locale, because we'll get different prices back, for example, in different locales. And then there's some sort of key that is the cache key, effectively, that defines how we identify that thing, which is a combination of the work ID and the locale, because those are the things that change. And then if one of those queries, if we're mashing these things together and executing them in parallel or whatever, if one of those queries returns like work ID 1 locale US, and then another query needs to get that, rather than making a call to the backend service, it knows it's already got it in memory and it will return it. So Fetch has an in-memory support for that, and we've extended it to use our generic cache. So we've just plugged in a cache, which again is in memory, but you could do other stuff if you wanted to, like point it at a database or memcache or some other, system that you have to store that. So yes, Sangria has a story around that, but it's only in the GraphQL layer. So if the GraphQL layer does that stuff, it's okay, but if something down below needs to get that, then you're hosed. You're basically making those requests again and you can't reuse it. So we use Fetch to do that, which is pretty awesome. It works pretty well.
So I had a question just about so I think you kind of answered some of this already, but I'll ask anyway. So I'm interested in the gap between the semantics that you kind of demonstrated and what's provided to you by GraphQL or Sangria. So, like, what tests are you writing? Like, it seems like some things are catched just by type checking them.
Ah, yeah.
Say, here's a schema, it generates a
Yep.
type checking against that.
That's a great question.
What is missing? So
Yeah.
response times, maybe other.
Let me give you a very high-level answer. I don't know how you all feel about testing, but I'm old enough to have gone through you need to test everything, 100% test-driven development. Agile's awesome, turn the nodes up to 11. I don't think that anymore. I'm kind of like post-testing, post-agile, and I'd rather everything's a trade-off, right? And the older you get in your career, the more you think there's lots of stuff I don't know and that everything's a trade-off. So in our case, we chose to trade off. There were some acceptable risks that we were prepared to take. So caveat my answer with that. So what I mean by that is we had no users. So getting to market is better than making it test at 100%. So we took some acceptable risks. It's one of the reasons we chose Scala, because it has a compiler rather than say Ruby, because we can catch a certain class of things, and the trade-off in terms of effort to get the risks that we're prepared to accept is such that we're happy, and we can go to market and we can build it with a team of 3, and we can make, like, I don't know how much we make, like I'm going to make up a number, $50,000 a day from this, right? Like, so you can do that from nothing. So yeah, tests, we test a lot of the lower level stuff, and we kind of use state-based testing for that. We use Scala check for a lot of that testing. The lower level things, we don't really test this level, which is the fetching. We have very high level tests as well that I call happy days tests. So we'll construct a query that the client would send, and we have those hard coded. Sangria's got a macro that does compile time checking of those queries if you want to use it as well. We don't use it only because I didn't know it was there when I built all our infrastructure, and I can't be asked going back and fixing it. We basically, every new feature that we write, we build an exhaustive query that tests all of the fields, and then we just whack it at the query interpreter, and it goes and runs the query, and then we just make sure it doesn't error out. So we don't do anything with the results. So we kind of do testing down here and testing here, and we have a level of HTTP. I'll show you the API tests.
And I guess you're also, like, your individual services, so say using Postgres or something, you're counting on it has correct semantics for.
Yeah, all of our Ruby developers do like test-driven development, so they're all awesome, and there's a lot of stuff there. So yeah, we're just kind of aggregating stuff and putting it together, so it's okay. We do have HTTP level tests, but again, they're really simple tests. Like, you know, a get on our health check endpoint returns okay, awesome. Like, that's it. Our GraphQL endpoint supports gets and posts. That's literally it, because that's the only thing we expose to the world, and then everything else is inside that query. So we kind of test here happy days and here low-level Scala check, and then we don't really test anything else in between, which has been okay for now. I'm not saying that's
Catastrophe so far?
no catastrophe so far. Actually, if anything, the server's been like rock solid. So yeah, I don't know how long I should keep talking for.
Apart from the fact that we make a terrible Scala city talk, why Scala? Why not one?
Ah, so when I was practicing this talk this afternoon, I actually prepared 2 talks. Let me open my other talk. I gave this talk internally because, like I said, we have about, it's a BFF, we have about, I'm going to say 50 engineers, give or take, and I'd say they fall into probably 3 camps. We've got newer, younger guys that are mostly front end, so they're JavaScript-y kind of people. We've got guys who are kind of my age, who are JVM, Java, Enterprise, J2EE, EJB, you know, have been through that kind of people. And then we've got this kind of drunk the Kool-Aid Ruby developers in the middle. And we wanted to kind of walk people through while we made certain choices. So the TLDR of that is this. It was the team's choice, because everyone's like, why would you pick this? Tom picked this. Tom likes Scala, he's going to do Scala. I'm like, no, the team chose it. So, you know, yes, I kind of did, but also the team was behind the decision. And the team was behind the decision, one, because I don't know how many of you guys know Kevin O'Neill. Jed probably might. He's a very opinionated guy in Melbourne FP community. One of the people we hired, she'd worked with Kev, and kind of Kev had indoctrinated her into FP. So I didn't know this at the time, and we hired her, and she came in, and she was a Swift developer. She was working on the mobile app, and I don't know if you know anything about Swift, but I don't really, but I've done like 7 years of Objective-C development, so I know a lot about that ecosystem. But Swift is syntactically very similar to Scala. and it's semantically very similar in that it's trying to bridge this world between object-oriented and this kind of legacy, like the JVM for Scala, or NS object and the world of Objective-C, and all the taking the programmers with it, and this new shiny functional world, but not wanting to go too far, but wanting to go enough that moves everyone forwards. So Swift is comes from a similar mindset, and they've made different trade-offs, but effectively you get the same kind of half-ass hybrid as you do in Scala. So we had a team that knew Swift, not to put it too strongly. We had a team that knew Swift, and we had a team that that were comfortable with a type system as opposed to the Ruby guys or the JavaScript guys. And we had people that were on board already with a type system. And we like the ability of people to move across platforms. So we don't want to hire like an iOS engineer or a Ruby engineer or a React engineer. We want to hire an engineer that can move across these things, and we want to be able to pair, and we want to be able to take a piece of work from like, hey, I'm now sitting down talking to a user, to I'm now talking with the designer, to I'm building the user interface, to I'm building the backend service, to I'm then building whatever needs to integrate with the database. You want to be able to take that end to end, right? And there's lots of value in being able to do that for us as an organization. So it made sense to let them move across those stacks. We call them stacks. And our goal for our team this year is N+1 stacks. So we want everyone to learn one more stack than they're already comfortable with. So it was right for that. And we'd done a bunch of things. So this is kind of about the team. We'd done a bunch of things that showed that our existing technology choices wouldn't scale to the needs that we'd done. So some really simple load modeling, like how many users do we expect? How many of them are going to download the app? How many of them are going to run the app? How many sessions a day are we going to do? Based upon our website traffic. And we modeled that out. And we were going to have to run like 30 app servers if we did it in Ruby. So we were going to get commensurate load to the main website within about 7 or 8 months at worldwide release. And at the time, I think that was costing us like 100 grand a month or something for our server infrastructure. So it's like, we don't want to do this, right? We don't want to double our server costs. We want to reduce them, if anything. So with this system, I'll stop talking out my ass and I'll show you something. So we use Gatling to do some load testing. I don't know if anyone's used Gatling as a load test tool. It's okay. I come from JMeter, Jed, so like Gatling's better than JMeter. Yeah, but we use Gatling, and with Gatling, we built the scenario of the typical app startup, which is basically the app starts up, it registers itself with the server, so it sends all the app version and its push notification token and stuff to the server. And then it does some initial kind of bootstrappy things, like it asks for the initial feed, it asks for a bunch of configuration for like what the menus are and stuff like that. So we modeled that out, and I didn't really push it, but you're easily able to, both with load generation and the server running on like this machine, serve 10,000 users, where a user is like those 3 or 4 queries within a minute. So you're easily able to push it to like 30,000 requests. Like our website is just serving about 40,000 requests a minute now across like whatever many app servers that we're running, with lots of caching in between, like in Nginx and in Edgecast and in various other things, Cloudflare. So we can run the same as the website on like my desktop. So there's a bunch of decisions on that. Other teams have gone a different way. Like we've got one team building some stuff in Go. They're doing different things for different reasons. So yeah, it's a team choice, and the team has to support it. If you build it, you run it. So you've got to be comfortable running it and maintaining it. And we were able to bring up that Swift developer that I spoke about. Within about 2 weeks, she was actually contributing more to the code base than me. We've got 3 others, 2 of which contribute actively on the server now. It's taken them a bit longer, but one of them has got a Delphi background, so like there's a bit more learning curve for him. But so I'm not making any judgments. I used to do Delphi. So yeah, so it depends. So it was the right choice for the job. Other teams will make different trade-offs for their particular scenario. Like one of the teams were new and they wanted to learn cool stuff, and they had lots of young guys, and they picked Go. Like I couldn't talk them out of it, but yeah. But they've got to maintain it. Did it work? It's in production.
That's, yeah.
I don't know, it's not one of my teams, so I don't know.
We'll have two more questions. One.
Does GraphQL have any? Sorry, does GraphQL have any opinion on updates sent from clients? So just pushing updates or updates from the server back to the client?
Yeah, so that's the subscription thing that Ben was talking about. Yep.
Mutations. So that's what it is.
Yeah, there's kind of, yeah. So subscriptions is probably what you mean, and I don't know a lot about them because I've never had to use them. So I'm not going to talk out of my ass because I don't really know. But mutations and queries are things that are in the kind of core of the spec. And what that means is you can do read-only operations with the server, that's a query, or you can do mutations, which are like write operations. So you can, and they're namespaced. They're actually the same thing. There's nothing magical that'll stop you doing one or the other. But so you could write a query that mutates data. But, excuse me, there's no tool that's going to stop you within GraphQL, but they're namespaced. So you can at least, you have to actually write mutation blah or query blah, and it kind of splits it into the namespace. And each one, because it's kind of typed, I suppose, is in a different kind of tree of the schema. So you can't suddenly go, hey, go and register my device with the server, but also go and, you know, I don't know, return a product. Or you can't return a product and accidentally register a device. You actually have to explicitly call them out, which is handy. So I'm not sure if that's what you mean, but subscriptions is probably the thing that you mean. And you can do that over WebSockets, I think, or HTTP.
So it really is CQR separation. That's the, it's, you know, command query separation really being that.
It's based on the flux architecture.
Press the button.
Press the button.
Based on the flux architecture, so you have actions, so basically actions rather than mutations. And subscriptions is currently under authorship in the main GraphQL spec. So it's coming soon.
So ask someone who knows. Awesome.
One more question?
So back on the sort of the business value side, recognizing of course that GraphQL looks awesome, you know, from that, you know, admittedly contrived example, but also
Yeah.
And recognizing that Facebook is a pretty good track record. Like it's another standard, right? So like, you know, we've had other things. We had Breeze. I can't think of any other names right now, but certainly what do you think about this one specifically? Also, what are your thoughts on how you guys, like, you pitched it as a thing that, like, you know, clients can consume whatever they want. That's awesome. But this, you then also showed us your use case, which is that largely internally, you know, people aren't quite sure what they want, but then in production, you do know.
Yes. By the time you hit production, you know what you want. Yes. Yep.
Can you go into that?
Sure. I'm not sure what your question is, but I'll talk about that.
Your thoughts on, you know,
If you ask our client devs, and I have, and they've told me, they don't like GraphQL. Which is interesting because it's what it was built for. And I think the reason they don't like it is because they have to build lots of infrastructure around it. So I'll give you an example. If you ask for a list of our available products, which is what I showed you, you'll get back a representation of a product. If you then click on that, you'll go to a details screen, and that's a different representation of that product. Now, say you're going to model that in Swift code. Say one of them had pricing, but the other one didn't. Do you make the pricing optional? Or do you have two different objects that represent that in your code base? Like, you start to get into those discussions, and some people just go, let's just take the superset and make everything optional. And other people, like there's generators that do this, will generate like query-specific, I'm going to call them domain model objects. So a product in this view is called like, I don't know, the details product, and this one's called the list product or something. And they have different fields. We didn't see a lot of bang for our buck in doing a lot of that originally, so we've basically handcrafted a lot of things. So we don't have a GraphQL library on the client, for example. We just send queries across HTTP and get responses back and use a JSON parser to parse them. So they don't see a lot of benefit. And like you say, by the time it gets to them, because we're now more in a mature stage of the product development, not like we were at the start, the designers are working with the engineers, talking to users, so by the time it gets to build anything, they kind of know what they want. And we might do some subsequent validations on it with users, but 95% of it's going to stay the same. So they don't get that advantage of moving quickly. If you're going to build a general purpose API that like represented your entire data set, I think it makes sense. For a bunch of other reasons, I think it makes sense. Like it's really easy to add new stuff. You get documentation for free. It's very easy to interactively build queries so that you can kind of like literally we just create a pull request, someone merges it, it gets deployed, and then magically the client developers know what they're doing. Like nobody actually has to talk to each other, which is great. I'm being sarcastic. So, you know, they can get up and running really quickly, but it doesn't give them that bang for their buck anymore. We do have another team looking at GraphQL, but mainly that's because you get a bunch of support with React through it, and they're building some React-based components on top of it. So there's other reasons you might choose it. So I think if you needed to do stuff really quickly and you didn't know what you wanted to do, it's good. If you wanted to add new stuff quickly, then it's good. If you've got like something that models the world, like your world or a particular domain, then it's good because you can then traverse through it. And if you've got lots of different disparate clients, like say we had an Android app, then it might make more sense because the Android app might want different things than the iOS app for various reasons. So I don't know. I don't think it's a silver bullet for anything, but it's quite handy and I'd certainly use it again and advise other teams to use it again rather than hand roll their own things. And it answers things like some of the questions like pagination and under versus overfetching and standards and things like that. So yeah.
All right.
I'll shut up.
Run out of time.
Hand it over to Brian.
So yeah, thanks very much.